Okay, so our toy is Driving Dory. I'm Hadley. This is Andrew. This is Scott and David. And the story behind her is she was swimming in the ocean trying to find Nemo, and she got lost because, as you guys know, Dory's forgetful. And somehow she ended up on land. So now that she's stuck on land, she has to relearn how to balance and maneuver and find her way back to the ocean.
Okay, so for our target age group for this toy, we first looked at the movie Finding Dory, and really the movie's appropriate for all ages. So we next looked at the appropriate age group for driving a remote control car, and we figured this was about 6 years old just from looking at what remote control cars suggested. So that's how we decided the age group would be 6 and up. The purpose or the play value of the toy is it has 3 wheels, so it's kind of difficult to control. So there's a challenging portion of it. And then also, we figured, if you were with your friends, you could set up an obstacle course or something and have a competition to see who could navigate the obstacle course the best. And then also, in the original design, we were going to have Dory be clumsy. So you would have to try to keep her upright, but you can see the wheels are a little too big, and she's not very clumsy anymore.
So here's a quick look inside of our model. Here we have the blue body of the Dory, and the side fin is just mounted with this rod that we glued on the inside. In the red, you can kind of see behind the wheel there's just a basic driving motor that we took out of an RC car. And so we just rigged that up to a new set of wheels for her. And then the steering motor in the back in the green is also, we took it out of an RC truck. We had to convert, so that's set up for linear motion. So we have this yellow linkage that converts the linear motion into rotational motion, and where that hooks into the fin. And that back fin there has the third wheel. So that was kind of our idea, was that it was a little bit challenging to drive, which kind of gave you the feeling of navigating Dory being a little bit clumsy. We have another view here of the outside. As you can see, that gets a good view of the body and the wheels. We have a quick video too, just to show you how the front wheels just move and spin forward, and the back fin turns. The friction of that back wheel is going to cause some sort of turning. So, yeah, I'll pass it to David to talk about assembly.
To go from our 3D printed parts to our final design, there's many things we had to do. Of course, sand the body down to make for a smooth finish for the paint. We had to Dremel the holes for the axles because we weren't quite sure how the motor was going to align in with the size of the wheels that we're going to get. Dremel holes for the fins. These fins actually do move on their own. Let's see what else. We use modeling clay to better round the eyes to kind of give it that rounded feature. Same with the cheeks to give it the true Dory look. Painting and mounting inside of the actual body had to be adjusted to the actual size of the motors and the different clearances from the printer, and then it was just assembling after that.
So
You can see the tail kind of moving back and forth. We don't have as much range of motion as we would have liked, but we kind of just had to make do with what we had.
the largest issue we had, again, was being able to mount these motors inside of Dory. Go ahead. So we left a lot of assembly process post-modeling. We would have liked to cut maybe a slot or something in for this tail, or for the fin, sorry, to allow for increased range of motion. But because we didn't know exactly how the motors were going to fit, we kind of left that. And so there's still work to be done, but this is a good prototype showing just how Dory can be used as an RC car. Are there any questions?
As a pilot myself, have you ever thought of converting this into an airplane and use a kind of a tail dragger design with airplanes and test this in the wind?
We have not thought about that. We thought about having her go underwater at first and be an underwater fish, but those are all ideas I guess we could look at later.
Have you measured its current turning radius?
No.
Probably about the same as a bus right now.
Just a suggestion. So I haven't seen Finding Dory. I've saw Finding Nemo, so I can gather. But I think just to increase the market appeal, if you had some kind of like obstacles or something that came with it that could put around, so you had to like maneuver her through different terrain or things, you could increase the market appeal of the product.
Yeah, and one other thing we were talking about is making a Nemo so they could chase each other.
I do, just real quick. I like that idea. Also, where we were talking about the water too, I think that might help because kids are going to want to drive this into the water, whether it's designed for the water or not. So that is another idea to kind of try and keep them grounded, maybe.
I had come across, I don't know if you know about these wheels, but they're wheels that actually are just like wheels, but they have ball bearings all around it, so it allows side motion as well. So it could be something to incorporate in your design. I'm not sure if you heard of those.
We did initially really want to put a caster wheel in the back to allow full rotation. Due to size constraints, we couldn't find a caster wheel that was small enough to fit on that back fin. They were all like 2 inches or larger, and we really wanted.
A tip that I've learned from robotics is even just having you don't even need a wheel back there. It's just a low friction point that drags, allows more side than actually a wheel that actually tends to restrict.
That would be worth investigating. Yes.
I just want to say good job on the CAD model.
Thank you.
It's really good.
Thank you.
Great. I think you would close.